All right, I'd like to welcome everybody. Thanks for coming at this early hour to this beautiful place. This is the Pacific Science Center's 9th annual Foundations of Science Breakfast. You're all here, which is great. My name is Hanson Hosein. I'm the director of the Master of Communication and Digital Media program at the University of Washington, and I'm on the board of directors of the Science Center. And so obviously this event means a lot to me. First, I'd like to recognize you all for coming out at this hour and for supporting the Science Center's really important mission. This is the largest turnout in the history of this event. We've been doing it now for a few years. And it's also the 50th anniversary of the Science Center, so it's a pretty big year. So you're part of something pretty special. So thank you all for coming. I first attended this event 2 years ago when Jeff Rakes, the CEO of the Gates Foundation, was speaking. And I got religion about the Science Center then. Jeff was speaking about STEM education and how important it is and how this state is at the bottom of the rankings for the country in terms of investment in science and education and how much time they spend. And I realized that with my young children that I had a duty and an obligation to help at least science tell its story better. So quickly I got enveloped into the Science Center ecosystem by being called to work on the board of directors as well as doing a number of events here. And I firmly believe that we have to do this, and the Science Center is part of that very important conversation, not just for our kids, not just to say that the Science Center is a great rainy day weekend place to take your kids, but this is actually really important to our regional economy as well. And if the Science Center doesn't lead the way, then we will be lost when it comes to the innovation economy in a very competitive situation around the world. We have a wonderful program for you today. I hope you'll learn a few new things about science and about the Science Center and gain new appreciation for what this institution is doing. Finally, I'd like to thank Nathan Myhrvold for joining us this morning for our special keynote discussion. We're going to do things a little bit differently because I know that there's going to be a lot of questions for Nathan, so we want to make sure we integrate it as much as possible into our conversation. So I'd like to introduce Nathan. Here's some inspiration for those questions in advance. He began college at age 14, had his PhD by 23. He studied with Stephen Hawking at Cambridge. And if you're feeling inadequate, it's okay. Because he actually dropped out a year later to start his own company, which was later bought by Microsoft. And that's what brought Nathan to our region. He ended up becoming the first chief technology officer for Microsoft and starting Microsoft Research. In 2001, he created Intellectual Ventures, which is a portfolio developer company, and has been very successful in managing thousands of patents along the way. But wait, there's more with Nathan. He's a photographer, he dabbles in paleontology, and he's a master French chef. His massive set of books, Modern Cuisine, which came out last year, where science meets cooking, is up for a James Beard Award this year, which is quite amazing. I actually interviewed Nathan last year on my television show, and we covered that at length. So there's quite a bit of genius, some quirkiness, and courage in pioneering new models, and obviously nothing but excellence with Nathan. So we'll primarily focus our conversation about what we need to assure a strong infrastructure around inquiry, innovation, and invention, particularly in our region served by the Science Center. We also want to explore Nathan's innovative business models, some of which have attracted a bit of controversy over the last year. And ultimately, we're looking to the future, and we want to tie the inspiration that he brings to science to the mission of the Science Center. And so now I will leave you for a few minutes to enjoy breakfast and obviously write down your questions and with your name, if you've got any, we'll pick them up and again, integrate them into our conversation in a few minutes. Thank you very much for joining us and see you soon. Nathan, good to see you again.
Yep.
Thanks for coming and joining us. We thought we'd make this an interactive conversation. Given we have a short period of time together, wanted to cover as much as possible. And I've interviewed Nathan before, and he's just, the diversity and wealth of subject that we can cover is actually pretty expansive. So I thought we'd get right to it. You saw these amazing kids doing incredible things and being utterly inspired by science.
I thought it was really a Seattle demo. You know, anywhere else in the city or anywhere else in the world, they use the sun for their radiometers. We need flashlights.
That's right. Flashlights are brighter here than the sun, right? So when you look at your own life, when you look at these kids, well, adults now, what inspired you to go into science? You started college when you were 14.
According to I was born in Seattle and lived here for 2 years before my family moved. I had no say in the matter. And my mom says when I was around 2, I started telling her I was going to be a scientist.
Wow, that early?
Yeah.
What was in your genetic makeup that forced that?
I don't know. You know, it's I've always thought that science was a fantastic thing to do.
And so when you look at these two young people who are scientists or about to become scientists, and they look at you, studied with Stephen Hawking, PhD by 23, you're a bit of an anomaly. So what...
That's the polite word.
What inspiration can they find in you or just in the world around them if they want to pursue science?
Well, there's lots of different kinds of science, I think, is the first point. Science spans a wide range of things. If you said writing, for example, people understand writing includes things like newspaper journalism and poetry, and they're actually quite different, and tons of other things in between. Science is at least as broad. Being a high school science teacher, for example, is very different than being a research scientist. Being a research scientist is very different if you're an oceanographer, for example, going to various parts of the world. I know Julian Sachs, who's an oceanographer at UW. He goes on these expeditions all over the world trying to understand past climate. That's very different than a theoretical physicist who winds up spending most of their time thinking about very abstract thoughts about the origins of the universe, for example, or what the fundamental forces of nature are. So science is a rich, broad field. Unfortunately, we've not done a great job of explaining that to people. And I think one of the big problems for science is that the set of things you have to do from sort of elementary school onward to then pursue science in a serious way is kind of a hazing ritual in some sense. There's a lot of hurdles you have to jump through. There's a lot of things that are off-putting. Many of them are off-putting even more to girls than they are to boys, for example. They're off-putting to people in minority groups who don't think that their folks, because they don't see role models as clearly that, oh yes, I can be a scientist. If you were not exposed to the right things early on, you wouldn't even know in general, most of us here in this room probably have a job that we didn't know existed when we were 10 or 12 years old. Okay, it's just, unless you're like a fireman, that's true.
Any firemen here?
Firemen or maybe a doctor, or actually there's one great exception. I do a lot of work in paleontology. Every single dinosaur paleontologist loved dinosaurs as a child. And people ask me, well, how'd you get interested in dinosaurs? I said, that's the wrong question. It's how come everyone else lost interest? But because we didn't know, none of us really knew that this job existed when we were little. Well, for many jobs, that's okay, because you don't actually have to specialize until much later. But if you get turned off of science and math very early on, it's very hard to later come back and say, oh yeah, I'm going to get back on that train. And so unwittingly, when kids are 10 or 12, and this also going forward, but even as early as that, they start making decisions, or decisions are made for them, in part because they don't understand that this is foreclosing a whole set of possible futures. And I don't think everyone should be a scientist. Okay? And someone asked me recently, should more girls be scientists? And I said, well, it's not that they should be. I don't want to dictatorially say they should be. But I think it's a tragedy that more women don't have the option, or feel they have the option, because of a whole set of small decisions. The cumulative effect of such is such that they don't go on in these sort of STEM topics. And because it's the path not taken, and it's one that you never realized you were not taking, that seems to be the tragedy to me.
So how do we address this?
Well, I wish I had a simple answer. Unfortunately, a lot of things are a death of 1,000 cuts. It's a lot of little things. Role models are an issue. So if there are great role models, there's lots of evidence that shows that people say, hey, I can go and be this, I can go and do that, because I see this other person who is like me. If all of the role models that I see are people who are not like me, that's harder. Obviously, you also need to have a better educational system. No one is born, none of us was born with the information that we currently have. In all of the jobs and professions and activities everyone in this room has, we learned it all. And if you don't as a society, if you don't invest in education well enough, you foreclose a lot of options for your citizens. And it's embarrassing that Washington State ranks so low, not only in the nation, but overall we're ranking lower in the world.
And when you look at the infrastructure that we have here to inspire that innovation and invention, do we have, is it just the education? Do we need more? Is there something else that we need to actually make that happen?
There's lots of things that we need, but the interesting thing is if I look at Seattle as a community, or I look at the country, either way, the higher education, in graduate school, we still have the best graduate schools in the world. University of Washington is a fantastic school in lots and lots of science and math areas. The medical school is kind of the Rodney Dangerfield of things, because they get no respect, right? That's the joke. But UW is the second highest research funding from NIH of any medical school in the world. Okay, the highest is Harvard, and the second is UW. And as much as we love UW, most people don't think of UW as being second to Harvard in that, but they are. So, and the same thing is true not only in this community, but around the country. There's great graduate education. And there's very good college level education. And of course, you can always quibble and you can always want to improve. But the real tragedy of the United States is not at the highest level. It's also not at the, are there jobs for people or economic incentive for people? I mean, look at, again, Seattle as a microcosm. You have Microsoft and you have Amazon, but you've got dozens of biotech companies. You've got all kinds of science, engineering, and mathematics-oriented things. Boeing, of course. A tremendous amount of economic motivation. So we don't lack, oh yeah, no one's becoming a scientist or an engineer because they can't get a job. No, that's just the opposite is true. The problem is in the earliest stages of education, where we do a systematically poor job, actually across the board, regardless of what socioeconomic thing you're in, but especially bad in the disadvantaged parts of the community. And so I think the real issue is the K through 12 education that does a poor job of setting us up for all of the rest. And again, of course you can say, oh, we ought to have more research funding. And of course, at the graduate level. And of course you can always quibble. But our biggest problem as a society is we don't know what to do in that 0 to 12 thing. And it's a very complicated problem.
So when we look now at you, and the Science Center says to inspire lifelong interest in science, you, despite your success in business, you seem to continue to actually harbor that lifelong interest yourself. You just recently published a paper on climate change, for example. Yeah. And you're open to this notion that your ideas continue to evolve even on climate change. What were your findings around that? Because I think they were quite stark in terms of what you came up with.
Yeah, unfortunately, climate change is not a good news topic. So the paper that I did with a guy named Ken Caldera at Stanford is we looked at how you could actually make a transition from the energy infrastructure we have today to some lower carbon emission infrastructure. Now, that's challenging because it takes energy to make energy. You have to invest a lot of energy in, say, creating a solar plant or a wind plant. It's a little bit like this hotel. Okay, when people built this hotel, they borrowed a pile of money to buy the land, to dig a big hole, and to build a building. And the first day that the Four Seasons opened, they couldn't charge people $1 million a night for the hotel rooms. They were charging them whatever they charge. And so there was only over a period of time that the ongoing operation of the Four Seasons would pay back, right? And if you're a real estate developer, your biggest issue is, okay, do I have a cash flow problem where the amount of money I borrowed and the debt service on the loan, can I match that with my ongoing things? Because I know I'm going to lose money for a while, but is a while a little while or a long while? Well, there's a very similar thing with energy. If I build a solar plant or a wind plant or a nuclear plant, I invest a lot of energy and therefore emissions, CO2, to build it. That's like the loan. Then as I operate it, because if I got to turn off a coal plant or some other dirty plant, I'm making profit, very much like the revenue that you get from the hotel. Well, over a period of time, that will break even and then become profitable, just like the hotel would eventually become profitable. Well, no one had ever done the calculation to say, well, how long does that take? And so we did, and we did this for essentially every kind of clean energy and for also less clean energy. So we did it for natural gas, we did it for solar thermal, solar photovoltaic, wind, nuclear, carbon capture and storage, almost every major thing, and say, okay, suppose we took today's infrastructure and we converted it to this clean energy. And the radical extreme is say, suppose we converted it all in 1 year. Now, there's no way you could do that. You can't build the plants in a year, you can't, no one would have the money or the willpower or whatever. Then we also said, let's do it at 100 years. And then, because once you program the computer, you can do all the others. Every transition in between, to say, okay, so what are our options and how long does it take? And can we, suppose that we all got the willpower to convert over to renewable energy in a year or 10 years or 40 years, how long does it take for that to help the climate? And the answer is it takes a really long time. Back in the terms of the hotel, it's a long time before you break even. And the amount of time depends on which technology you switch to. Some of the technologies, though, you never really break even. Interestingly enough, one of those is natural gas. So natural gas has gotten to be super cheap because of this technology called fracking. In its own way, fracking is the energy miracle of our time. Silicon Valley, all these clean tech companies are out there trying to create an energy miracle. Well, fracking is a miracle. Okay, it's taken the amount of natural gas in the world and enormously increased the possible thing. It's dropped the price. The problem for climate change is all that cheap gas won't pay off. So if you convert, naively, natural gas emits about half of what coal emits. You'd say, oh, that's great. We'll convert from natural gas to coal, from coal to natural gas. It'll be a bridge to the future of other things. We'll save half the emissions, half. Well, it turns out that all of the phenomena in climate change are nonlinear. And this half isn't enough. So if you said, well, how long will it take before I get even a 10% reduction in the actual temperature of climate versus continuing with coal? It's more than 100 years with natural gas. If I say, if I want a 25% reduction in the temperature versus coal, 300-400 years. So natural gas doesn't help you at all, effectively. It's just you can convert tomorrow to natural gas and it will not make a significant difference. What the research shows is that in order to make a significant difference, you need to have about a factor of 10 lower emissions than coal, or it's kind of not worth it.
So we're going to drive our economy into the ground trying to make that happen? It sounds pretty radical to me.
Well, here's the fact. There's sort of two attitudes about energy. One attitude is best summed up by a book I had as a child. It was The Little Engine That Could.
It's a great science book, isn't it?
And the little train is saying, I think I can, I think I can, I think I can, I think I can. I remember reading that and going around the house saying, I think I can, I think I can. And hey, it worked out. So it's a great book and it's a great thing. And there are some things in life where having a positive attitude and willpower is really what it takes. And so there's one set of people in the climate change community who are going around saying, I think I can, I think I can. And they would say, oh, we already know how to do it. The technology is already in hand. We already know. So that's one extreme. The other extreme, Bill Gates has been recently going around giving a bunch of speeches on energy, where he says we need an energy miracle. We need maybe more than one energy miracle. We need some new invention, some innovation in the technology of energy. And if we don't have that fundamental technical innovation, we don't have any hope. Now, those are two very stark differences. And I subscribe much more to Bill's, now, for a variety of reasons. Now, if you say, well, isn't that depressing, we need a miracle? What Bill would say, and I think I would say, is no. The technology industry is in the miracle business. Okay, if you look at the cell phones we all have, if you look at all of the technology that we use in our everyday life, it's a damn miracle. My kids were smaller. Remember, we were watching a James Bond movie. And at some point, James Bond knows this information that'll save the world, and he's desperately trying to find a payphone. And my kids say, "What's that? And why doesn't he just use his cell phone?" Right? In the lifetimes of everyone in this room, look at those miracles that have created. Well, in energy, we need some miracles. The problem is that the energy industry is not one that's prone to miracle creation. The total amount of R&D effort that goes into great new R&D in energy is tiny compared to the size of the energy problem. Just infinitesimal. So it's not like, if you looked at the size of the cell phone market versus the amount of R&D of people trying to do cool things in cell phones, it's way better than it is in energy, even though it's for society, it's a much more important problem. Another problem with energy is the price of energy goes up and down and up and down and up and down. When the price is up, then there's lots of investment in new things. But in the last decade, oil has been a high of $160 a barrel and a low of 10. Natural gas now, the technological miracle of fracking, is going to frack up renewable energy because all of a sudden you have this, it's so damn cheap. It's so damn available. So you have a huge economic incentive, and that pulls the rug out from under the guys that are out there trying to make because new technology in its first form doesn't work very well. I mean, here's another story, watching a thing on TV with my kids. There was a movie called Barbarians at the Gates, a TV movie. It was about this big takeover of RGR Nabisco in the 80s. And so it was on TV, and so my boys put it on. And they pull out a cell phone, which was this giant brick-like thing. And at the time, they were all big shots. So cell phones were, $1,000, and it was like a big miracle that they could pull out this giant, two-hand hold thing. And my kids are laughing at this. But early technology always has some adoption problems. So imagine that you have an adoption problem with this. Look at the Tesla, electric car. It's a great car in lots of ways, but it's got some significant drawbacks compared to gas. So you have to buy it knowing, if I bought a Porsche instead, and my Porsche is running low, I pull into any gas station, and 5 minutes later, I'm good for 300-400 miles. My Tesla, oops, I have to find a charging station, and it takes overnight, and a variety of things like that. So when you have this competitive landscape and you have a seesaw price, it's hard for people to make innovations in energy. Now, there's lots of people trying. There's a bunch of Seattle companies that are trying. My own company is trying. We do a variety of both energy inventions and we've also spun out a company called TerraPower that's working on a very ambitious new kind of nuclear power reactor. So we're trying, but I tell you, it's an uphill battle.
So would you say that you're in the business of miracles then? Because you call
Oh, absolutely. We are absolutely in the miracle business. We're about investing in invention. We're trying to find new miracles. Now, the problem is miracles are few and far between. When I used to run Microsoft Research, we'd have all of these visitors come in. And we get the same thing at Intellectual Ventures now. People come and say, "So, what's your latest breakthrough?" And I'd say, okay, well, guys, breakthroughs are things that happen rarely, okay? But there's a mentality of, hey, you ought to have a breakthrough every day. If you look at physics, the field I used to be in, well, there's Newton and there's Einstein. And there's a whole lot of other great stuff that happened, and I could then tell you the next level. But a guy like Newton or Einstein comes around every 500 years. And it's not just I said a guy like that, of course, it could be a woman like that, but it's also not just the person. The time had to be right for that. There undoubtedly were people that were just as intellectually capable as Newton and Einstein that were around at a time when the things that they got were less. Biology is a fantastic field. One of my own sons is now studying systems biology at Harvard in graduate school. One of the interesting things, if you compare biology to physics, is The Origin of Species, Charles Darwin's great work, published in 1859. The Principia Mathematica, Newton's great work, 1659, around that. So almost exactly 200 years difference between the two. One of the interesting things about physics is physics had a fundamental theoretical framework 200 years before biology did. There's nothing fair about this. There's a variety of reasons that it occurred that way. It could have been the other way, though. Some of Newton's great insights didn't have to, most scholars believe now, apocryphal story of the apple hitting him on the head. He didn't have to have figured out gravity when he did, or a variety of other things when he did. And if you say who was the second guy, the second guy in physics to Newton is Einstein. Who is the second guy to Darwin in biology? Well, we're hoping we have one. And I'm sure there will be one. And of course, there's great discoveries. Francis Crick and James Watson's empirical discovery, not theoretical, was of course enormously important. So maybe that's your second one, but it's not quite the same as a theoretical framework that helps you understand. So, it's a long, drawn-out answer to your question. Breakthroughs take a while, and so when we're in the miracle business, you have to fail a lot. And so, although I'm in the miracle business, I'm even more in the failure business. And it's got to be okay to fail. It's actually one of the things that makes U.S. business strong, Silicon Valley, that whole culture of entrepreneurship. There's lots of great entrepreneurs who failed their first and second time out in a whole variety of ways, and that's okay. And there's lots of other countries that's much less okay. You fail at something and you're kind of branded. So yeah, we're in the miracle business, but we're even more in the failure business. And you have to accept that up front. If you want to always be successful, don't try to be an inventor. You still can be a great, Microsoft, when we started a research group, we would have these engineers from the product division want to move over into research. And one of the things I would ask them is, do you get like professional satisfaction from really understanding what you do and being confident of your abilities? And I'd say, oh, yes. I'd say, oh, God, that's too bad. Lewis and Clark had a terrible trip. Okay? They were chased by grizzlies. They were eaten by mosquitoes. They would have all died except for a 16-year-old Indian girl took pity on them and saved them. If you're an explorer, you are lost and confused and failing much more often than you're succeeding. And you got to be okay with that. And there's a wonderful romantic notion of that. Now, meanwhile, there's other kinds of engineering where that's not true. Bridges, the guys that design bridges, you kind of want them to always succeed. And unfortunately, Washington State is the poster child for bad bridge design. In high school physics, everyone sees the Galloping Gertie, the Tacoma Narrows Bridge, collapsing. But within the last 20 years, we sank I-90. If you want to be in an area that's always about certainty, that's great. And you really want your surgeon to be that way. You want your bridge engineer. You want your guys at Boeing. You really want those guys to be sure of what they're doing. If you want to create miracles, you got to be willing to screw up, be confused, and be disappointed a lot of the time.
We're going to move to questions in a few minutes. We got a few minutes left, but I wanted to ask you, Intellectual Ventures owns thousands of patents. You've been in the news in the last year, especially at NPR and Stanford Journal, looking at your business model and saying that actually the miracle business is actually stifling innovation given how you do manage those patents. How do you respond to that?
Well, I think if you're not willing, not only do you have to be willing to fail, you have to be willing for people to ridicule you and call you names.
There's been some names.
And most great endeavors have exactly that. So venture capital was widely pilloried when it first came out. And you still see people sometimes call venture capitalists vulture capitalists. The private equity industry has arguably made a lot of positive contributions in helping refinance and restructure failing companies. But the great book, that movie I mentioned about RJR Nabisco, that was called Barbarians at the Gates, not smarter allocators of capital at the gates. The people, when you change the status quo, people get upset. And there are very powerful vested interests that feel threatened by the idea of people who will just go and invent a lot of new stuff and ask to get paid for it. But here's the interesting thing. When we started intellectual ventures, it was even more true that there was all of this. And big technology companies were publicly saying, oh, patents are terrible, and isn't it terrible we all get sued. If you look today, one of the most active litigants, or some of the most active litigants in this, are big tech companies.
Apple, Samsung.
Apple is out there very actively trying to protect the iPhone. And in the Walter Isaacson's biography of Steve Jobs, he doesn't mince any words. He thinks the Android system was stolen. Now, ultimately, that's a very complicated IP story. Whether morally it was stolen or not is a different question of whether they can make their patent thing stick. But there are more, intellectual property is actually more important to big companies every day, and I take that actually as vindication. And if we can succeed, it's possible with all of our thousands of patents, very few of those are miracles. But if we can succeed with our nuclear reactor, if we can succeed with some of the inventions that we have a whole program where we invent new technology for people in the developing world. If we can succeed at any one of those things, even a little bit, we'll have enormous impact. And I think that's more than worth it.
We're going to take a couple questions, so if there's a mic roaming around, we can do that. But I'm going to ask one question I got here already in advance, and we're going to switch to modernist cuisine. Your multi-tome successful, 60,000 sold, it sounds like, of your cookbook, right? So my daughter's favorite Pacific Science Center camp is Candyology. What module would you add to that camp, building upon your love for cooking science? So if we are teaching kids the science of cooking, what could we take from the work that you've done to actually make it fun?
Cooking is the only science experiment most people perform. Okay? And when you make a new recipe or you try to bake cookies for the first time, it's an experiment. And it's not always an experiment that succeeds, as we all know. And a lot of the reasons that things in the kitchen succeed or fail are due to very interesting things in basic science. So I think cooking is a great opportunity to connect people with science. And it's a great opportunity to say, hey, here's some things you can try at home, simple things, or here's an explanation for something that you see happen all the time. Here's why those croissants and muffins that are on all these tables actually are the way they are. They'd be hard as a brick, be like a hockey puck, if they weren't lightened by gas bubbles. And how those gas bubbles get made? Well, two different ways. In the case of the croissant, it's because a microorganism, yeast, generates carbon dioxide. It exhales CO2. In the case of the muffins, it's because there's a chemical reaction that makes CO2, a chemical reaction you can watch if you pour vinegar and baking soda together. And so I think that cooking is a terrific way to engage people in science. That's why we wrote the book. Because cooks at every level, including the best chefs in the world, don't always realize what some of the science behind what they're doing is.
So, cooking exhibit for the Science Center is coming. Do we have any questions from the tables? You can introduce yourself.
Good morning. I'm Nick Rushton from Wells Fargo Bank here in Seattle. I was just wondering if you could give us some thoughts on Stephen Hawking and what it was like to work with him.
So, it's very hard to feel sorry for yourself if you've ever worked for Stephen Hawking. If I'm having a bad day and I'm thinking, oh God, life sucks, and everyone has a day like that, they think, well, wait a minute, my legs work. I can talk. I can go to the bathroom by myself. Here's this guy who has enormous physical challenges. Just horrendous, things that would crush the spirit of essentially anyone else. And yet, he tells jokes all the time. He has this fantastic spirit. And in his own field, he has not only able to get by, he's one of the top people in the world. So it's incredibly inspiring working for Stephen, particularly because his personality is so terrific. There's a lot of honor and deference accorded professors, and then in the UK even more so, and then Stephen, because he's such a superstar. So here's a little story about Stephen. There was a conference that was going on at the time, this is way back when I worked for him. And the conference was right on the topic of one of the graduate students' thesis. So graduate students really wanted to go, but it was an invitation-only conference. And so Stephen tried to get him in, and they said, no, sorry, there's only one person can come from your department. So Stephen sent the graduate student with a note that said, I'm sorry you didn't have room for me. And of course, the people at the conference, it was unthinkable that the most senior person at the department wouldn't go. And the idea that Stephen would step aside for a graduate student just shocked the hell out of them, but there wasn't anything they could do. But the great thing about Stephen is he's a guy who would absolutely do that. No matter all of the other stuff, he'd step aside because it was more important to the graduate student than it was to him.
We've technically run out of time, but I'd like to take one more quick question because Nathan's been so beguiling here. I think we see a hand over there, or Amy.
Yes, my name is Dee Dickinson, and my background is in education. I have become increasingly concerned for many, many years about the anti-science, anti-technology abroad, not only in our state, but throughout the country. The Seattle Science Center, of course, is doing a fabulous job in the schools and generally in educating the community. But what are some of your ideas about how we counter the tremendous misinformation and outright lies that are often just blogged and perpetuated ad nauseum throughout society right now?
Well, I wish I had a simple answer to that, but I don't. It's a complicated problem, and unfortunately, it probably has a complicated answer. But here's a couple things that I'm sure will help. I think one is encouraging scientists to speak out and correct things that are wrong and to stand up for science. I think that's certainly part of it. Investing in science at every level, whether it's in the Pacific Science Center or similar science museums. The Science Museum as we know it today was invented by a guy named Frank Oppenheimer. He was the brother of the Oppenheimer that's famous for, a famous nuclear scientist was involved in the Manhattan Project. And he started this at the Exploratorium. There's other threads, it wasn't only that. But that was a fantastic thing to give kids a hands-on view of science, to create a museum that wasn't just a bunch of stuff in glass cases. Now, I love stuff in glass cases, and if you went to my office or my house, you'd see, my house is a glass case I put a lot of stuff in. And I never quite realized that meant that all the tour boats on the lake would stop in front of it, because I have a T-Rex in my living room. But the idea of getting people engaged is a great thing. But pushing our legislature to invest more in science and education, pushing back in every possible way, because this isn't. And then if you turn it around and say, why is there a lot of misinformation about science? Well, one is that scientists are scientists. They don't tend to be great slick spokespeople. It's always funny to me when you see celebrities being asked their position on lots of important topics. It's always funny to me on like ESPN or things like that, which I flip past occasionally and stop. I'm not really a sports person, but listening to some sports people talk is about as interesting as watching me play basketball. The thing that's great about those guys isn't their verbalization. Well, unfortunately, no, it's just true. Sorry. We really respect that team. We're going to go out there and try our best. That's like 90% of the interviews. Well, they're very good at what they do. Scientists, unfortunately, aren't that much better than the guys on ESPN. Okay, they may have more years of formal education, but they're not necessarily that articulate. Science is naturally a skeptical topic. Okay, so one of the classic problems that occurs when you try to bring science to policy questions of any sort is somebody asks the scientist, "Are you sure?" Okay, well, by the nature of science, that you can never be fully sure. And when the defense attorney uses that to try to get around DNA or other evidence, that's unfortunate. But of course, you can never be sure of anything. Climate change is one of the most vexing problems because large aspects of climate science are genuinely scientifically uncertain. Now, that doesn't mean you should ignore all of them. But if you take an honest scientist and you put them in front of a question and say, "Are you absolutely positive of this? Have you proven it?" Well, the way we'll prove most of this is by empirically measuring it. So the way we'll really know the temperature in 2100 is to wait until 2100 and take a thermometer. That's how we'll really know. But that'll be too late under a whole variety of theories. And unfortunately, then that causes science to get politicized. There was a big issue in the press about this set of emails from a client's climate research unit in the UK. Well, that's a great example of guys who were really trying to do science, but also got caught up in this polarization of this "are you sure" thing to the level that they did a lot of things that frankly did a disservice to their own science. If you're in an area where the world has thrown a spotlight on you, as climate science has, it behooves you to be more transparent, not less. Those guys went the opposite way, unfortunately. And then that causes credibility loss for the whole field, which is understandable, but that's very awkward. So I don't have a single answer other than to say scientists need to try better and society needs to try better.
Well, I think that's a great place for us to conclude. And Nathan, I actually think you're a pretty darn good storyteller, so thank you for your inspiration. And thank you for joining us. Thank you.
Great.
Thanks. You can just stay for a second. And Bryce, call Bryce back up to the stage to give a little bit of recognition to Nathan. Thank you, Nathan.